So there's the idea of using concentrated CO2 and pumping it into greenhouses, because in a greenhouse it's enclosed, so it might lose more CO2. There's no more air that can negatively affect plant growth. However, I want to talk about if we can develop a cheaper technology for this, some additional benefits. One benefit is that I forgot to list is better climate control. And we could do that because CO2 absorbs heat, so you could pump in more CO2 to make it hotter or cooler, depending on the day. Not only that could you make it hotter or cooler, you could also do other more complicated climate controls. You could remove more nitrogen out of it. So I'm going to say more than the CO2, nitrogen and everything removal. Removing nitrogen out of it, if you could do it cheaply. Nitrogen isn't required for a lot of stuff. Or oxygen removal. Oxygen is required for respiration stuff, but removing either nitrogen or oxygen could mean more water in a thing, which could help with controlling plant growth, as the plants will have more water. Or you can remove water for lower humidity to prevent funguses or some other things from growing. And water also has a heating up effect, so you could balance it out there. So water controlling the amount of nitrogen and oxygen. And nitrogen isn't that necessary for plants growth in the air. Now it is necessary in the soil, but nitrogen soil bacteria do not actually need that much nitrogen in the air, because there's always so much nitrogen in the air. You could also use it for faster for certain days. In certain days, they might use more CO2 than other days. So you could concentrate it so the rate could be sustained during days that they use more CO2, higher rate. CO2 is pumped in. And the same is with water stuff. Change it for the amount of days. Change the atmosphere. Days they use more water, have it more humid and keep the humidity more inside. That way you can get a little bit of benefits of having water but not enough for fungus. Another benefit is you could mimic Chem plants, which are a lot more photosynthetically efficient than your normal C3 or C4. To go over those terms briefly, C3 is normal photosynthesis, and it has a lot of problems because the enzyme that binds to oxygen to burn the sugar, to help burn sugar and stuff like that, also binds to CO2, and vice versa. And the problem with that is that some of the energy that goes into splitting up all these molecules instead gets lost into the other process where you burn it and doesn't convert to energy. So you want to separate the end product, is the oxygen given off, from the middle products. How do you do that? Well, plants have come up with two methods, Chem and C4, with C3 as being normal. C4 is C3 is the least efficient. C4 is more efficient, but more complicated, and then they spatially separate it out. Chem is even more efficient, and they temporarily separate out respiration and photosynthesis. Respiration is when you burn sugar for energy. Photosynthesis is when you make sugar for energy. Chem is by far the most efficient. The problem with Chem is it is slower because you're burning it during night, and you also don't open up your pores as much, which means you save water. So Chem plants use less water, but besides not opening up your pores as much, you can't, because your pores now open up and you're not pulling stuff from the soil constantly as much, and you're not pulling up oxygen and nitrogen, oxygen and stuff for other processes as much as anything. You can't grow as fast, so it's more efficient, but you can get less total power. It's kind of like the difference between having one very efficient solar cell and 10 million bad cheap ones, or something like that, with rates and stuff like that, or a car that can go really, really fast but uses up a ton of gas. I'm making more extreme one suggestions. Now, I don't know if there's any plant that's both, but I'm not aware of any. A lot of plants are C4, grasses, corn, and everything. So canned plants, maybe by pumping in a lot of CO2 during the day and then stop pumping it during night, you can mimic chem thing, and maybe they'll learn to be more chem-like. Some plants do have a rough circadian rhythm, as you can see with when the leaves are moving, the flowers and everything. So they might actually be able to adjust likely what they do throughout the day with pumping in CO2 or not. This will take a lot of experience to see if it's real or not. And by pumping in CO2 by pumping up this CO2, you can also do it with water, so they respirate more during certain times of day, or less when it's less hot or hotter, so they lose less water too. All these could be eventual advantages of the system. Another thing it could do is it could help kill bugs and pests. Bugs especially are sensitive to low oxygen levels, and pests and a lot of mammals and stuff are sensitive to high CO2 levels. So you could use this as a way of killing bugs without using harsh insecticides and pesticides, and maybe even some plants. Some plants are more sensitive to high CO2 levels than other plants, and actually produce less nutritious if the CO2 levels are too high. That's why this all has to be well controlled. Example is eucalyptus. And you would have to do research plant by plant. So this is why this is not just easy and all things to play around with. But you could kill bugs. Now you also kill good bugs. But the advantage is that this system, once you kill everything, you just let that stuff grow back, and it comes back. There's no long-lasting insecticides that are also harmful to people. That's the advantage. But it is a broad solution with many problems. Briefly, how would you concentrate CO2? Well, there's or water or oxygen or nitrogen. There's a couple of different ways. One is you get rid of the nitrogen, and that makes everything else go up. Nitrogen purification, pretty darn easy actually. And nitrogen purification depends on the level, but we don't need high levels. Is you can heat it up. Is that nitrogen moves a lot slower than CO2 or O2, and therefore you can use membranes that select the slower moving molecules, and the faster moving molecules just move out of the membrane. Well, nitrogen, when it's slow moving, can't move out of the membrane, it gets concentrated. And you can do this with complicated vortex tubes and stuff, which splits out stuff also with vortices with hot air and cold air. It has a hot air section and a cold air section that splits up using rotational. You can use a membranes or more. Oxygen, you can do similar, but not as selective with this, or you can use stuff that binds to oxygen, then you debind it to oxygen, concentrating the oxygen, or both. Oxygen can bind to a lot of things. You can think about how it binds to blood, a lot of chemicals. Now CO2 dissolves a lot better in a lot of liquids. You can look carbonate beverages and stuff because it can form an acid in a lot of liquids, or it can chemically react weakly with a lot of liquids or solids, and then you can debind with electricity or heat or something. You can also use that it has a bigger molecule size. Some other things which also use nitrogen and oxygen separating is that they have a small one. Molecule size, you can also separate it out with bigger molecules can travel through some membranes faster because they don't get stuck in small holes as much. So there's a bunch of things you can do there. Water filtering is dehumidifiers basically, and humidifiers. And you can store water for a couple days this way too. And if you keep water trapped in a system, you can actually save a lot of watering, because example is the rainforest. A lot of the water in the rainforest comes from the rainforest being recycled. So leaves evaporate and a lot of plants lose a lot of water, but then it becomes rain right over their own heads and waters down. The rain doesn't really travel far from where it started. So you have that whole recycling system, save a lot of water there. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is a really hard goal. With your help, I think I can do it. Also, if you have any ideas for future videos, comments, or suggestions, please leave them in the comment section below. Thank you very much. Goodbye.